After we've linked all the plans in the project, then we can begin modeling. So now if we take a look at the duct fittings, for example, if we zoom in on here, we can see that the branches are direct and go inside another duct, which in Revit we refer to them as taps. Also, as you can see, this tap fitting has an angle, and that is to help the air flow easier. So that'll make the air go this way easily, and then it's going to be leading to the subsequent terminals. Also in Revit we call a fitting like this one that has an angle, we call it a beveled tap to indicate that it has a beveled corner. Now as for the duct transitions, we usually use the 45-degree transitions, but also those angles may differ in the plans. For example, let's measure this one, going over to the Annotate tab, then get the Angular tool, and then I'm going to measure the angle between this line and this line. So as you can see, this angle is 14 degrees, but we usually use the 45-degree angles to make it more standard. So now we're going to go over to the Systems tab, and then we're going to get the Duct command. And now if we take a look in this drop down, we can see that there are 4 types of rectangular duct fittings. And the one that I'm going to be choosing is going to be this one that says radius elbows / taps. By radius elbows, it means that the angles of the elbows are going to be round. For example, like these elbows over here. And as for taps, it means that the branches that we're going to be adding to the ducts are going to be direct. So I'm going to select this one. Now we're going to have to edit this type. And first I'm going to rename it because we haven't drawn any ducts yet. So we could edit and rename this fitting type. So I'm just going to add the word beveled before taps. Then click OK. Now I'm going to edit the fittings. And first we're going to check all of the fittings that are defined for this type. For the elbows, we can see that this radius elbow family is being used, and it's also 1.5 W. Now this W is actually referring to the radius at which the elbow is turning, and basically that means that the radius of this arc is 1.5 times the width of the duct. So this W stands for the width, and I'm just going to change it to 1 W. Now these next 2 groups are actually correlated. The first one says that the preferred junction type is taps, and if we check the drop down, we also see T's. So we're going to keep it on taps like the plan. But now which tap family? We're going to need to define that family in this second group. So I'll hit Load Family. And right now we're in the Imperial folder. And the size values that we had in the plan were also in inches. So while we're here, we're going to go to the Duct folder. Then Fittings, which are the families that we want to find. Then we're going to go into Rectangular because the family is rectangular. And finally, we're going to go into Taps, and here I'm going to select this Beveled Tap family. This one's corner is going to be beveled, so we're going to click OK. And now that we've loaded the family, we're going to have to go over here to Junction, open the drop-down menu, and we're going to select that beveled family that we just loaded. Now this means that whenever we want to add a junction or a branch, then a beveled tap will also be placed to create that connection. Let's check the rest. We've got cross, 45-degree transition, rectangular to round transition, rectangular to oval transition, and we're not going to be making any changes to these. We're just going to keep the transitions as they are. And also, if you remember, I told you that I'm going to be using 45-degree transitions. Now, as for the remaining fittings like unions and caps, again, we're going to keep them as they are. What mattered most to us was the tap and a beveled family for that matter, which we adjusted. Click OK and OK. So now we're going to try to draw the ducts for around here, and then later we're going to place the terminals. The template that we've opened for our project was a metric template, and in this template we would be getting the duct sizes all in millimeters. But as you can see, the plan says that the duct sizes are in inches. So what we need to do is that we're going to have to change the project units. We're going to have to go over to the Manage tab, then click on Project Units, or we could just use its shortcut, which is UN. Now we're going to open this drop down, go to the HVAC discipline, then we're going to look through this list and find duct size. and then I click on the button in front of it to get this window. You see here, duct size. Now in this new window, we can see that it says the units are in millimeters. So I'm just going to open the drop down, select inches instead. And also, if you are trying to convert your values from millimeters to inches, that you have 2 decimal places for the rounding. Because if you don't, for example, it's going to round 11.59 to 12. And because of that, you might use the wrong size to draw your ducts. We can also have a unit symbol, so we're going to select the inch symbol. And then we're going to click OK and OK. Now, do you see how the width of the duct has changed to 11.81? So don't forget to also include the decimal places. Alright, so now if we want to check the items one by one, first we have the fitting type, which we've adjusted. And the system type of this duct is going to be supply air, because the air is coming from the fan coil and is being supplied. Then for the sizes, we're going to put 12 inches, move the mouse pointer out of the bar, and then we're going to click on the field in front of height, and again we're going to put 12 inches. As for the middle elevation, the architectural plane is going to determine that one's value. So it is best that we create a section first along this main duct line. Now, do you notice how it's not showing us the section? That's because so far I have adjusted the settings for the sections to be for plumbings. But I'm just going to place the section here anyway. So click. Then we also get a warning which says none of the created elements are visible in the floor plan. So this element that we just modeled, even as small as the section, is not visible here. Over here in the project browser palette, we're going to go to plumbing, then expand section, then open this one. Or for example, if you had several sections and you didn't know which number it was, you could open any one of them. Now once we've opened the section, we're going to have to go over to edit type. And as you can see here, we've adjusted the settings in a way that all the new sections that we create would be following the settings of the plumbing view template. So we're going to go over here, select mechanical this time, then click OK and OK. Now we're going to have to go back to the plan, then create a section, now click, and as you can see, the section is visible now. Another click here, and we're going to also make our section tighter so that it only covers the duct. Now, if you couldn't find the clips for that, you're going to have to go over here to far clip offset, which as you can see here, it says 23,000. So that's up to 23 meters. We're going to change that to 2,000. And now if you see here, now this distance is 2 meters or 2,000 millimeters. Now we can see the clip and we can use it to make the section tighter. And now it's 734. Now I'm going to right click on it, then go to view. And we were in the 5th floor. So let's go find it, the 5th level. And as you can see here, we've got some beams and the false ceiling. So the ceiling and beam are going to be our elevation limiters. And we're going to need to adjust our duct's elevation in a way that it goes between them. So first I'm going to use a line dimension to measure below the beam down to the FFL. And then we get 3,700. I'm going to also want there to be a 5 centimeter gap between the beam and the top of the duct. And that means that we're going to have to consider this 3.70 meters as 3.65 meters. In other words, it's going to be 3650. So I'm going to go back to the plan, then get the duct command, which I could go over to the Systems tab and click on the duct command, or I could use its shortcut, which is DT. Now we've got the elevation of the top of the duct, which was 3650. So we're going to go over to the Properties palette, where we can find this parameter that says upper and top elevation. In some older versions, it might be just top elevation. And basically that just means that the top elevation of the duct from the 5th FFL, we want that to be 3,650. Now after we've entered this value, based on the dimensions that we've entered for the duct, it's going to automatically calculate the middle elevation and the bottom elevation of the duct we need to draw. So I've adjusted these 4 items. We had fitting types, system type, the dimensions, and the elevation. Now we can go ahead and begin drawing. So I'm going to zoom in and click on the axis of the duct. Then I'm going to go all the way to before the transition and click again. And at this point the size changes to 10 by 8. So while we still have the duct command enabled, I'm going to click over here, enter 10, move the mouse out of the bar, then go back here and enter 8, go down to the drawing area and click. Now press escape. Let's go check this out in section, and now we're going to measure. We said we wanted the top elevation of the duct from the beam down to the FFL to be 3650, which is exactly what we got. I also wanted there to be a 5 centimeter gap between these two, and that's exactly the distance value between the beam and the top of the duct. And it's also going between the beam and the false ceiling. Now we get to the branches. We're going to get the duct command again, DT. And now let's go check the size. The sizes are 8 by 6, so we're going to enter here 8 and 6. Now we're not going to change anything else, and all we need to do is to click either on the edge of the duct, the axis, or on its bottom. I'm going to click on the axis of the duct approximately aligned with the axis of the branch, and then I'm going to go all the way to here and click again. Now as you can see, the position of this duct is a little different from the plan, but this small of a difference doesn't really matter. But if you want to draw exactly according to the plan, you can always use the align command. Then first click on the line on the plan, then on the edge of the duct to align them together. Now if we take a look over here, we can see that we did get the tap fitting. This is a bevel tap, but it's facing the wrong direction. All we need to do is to select it, and then we're going to find this double-ended arrow, then click on it to flip the fitting. Then it's going to be flipped by 180 degrees. So now I'm going to be drawing the rest of the branches the same way. First we're going to get the duct command. Size is 8 by 6 again. And now click over here and another here. Now while I still have the duct command enabled, I'm going to draw the rest of the branches, and then I'm going to flip their fittings. So click, then go near the terminal, click again. And now let's draw this one, click, go up near the terminal, click again, and press escape. Now I'm going to select this tap and flip it. Now let's go to the next one, select, and flip. Now let's go to this last one, select it first, and then flip it. Now this duct over here can't have an open end, because it's not like the air is going to be coming out this way. So we're going to have to cap this end. For that, we're going to have to select it first, and then we're going to go up here and click on Cap Open Ends. So this way, Rivet automatically identified that this selected duct had an open end on here, and then it placed a cap on it to prevent the air from going out. Now the next thing I'm going to do is I'm going to hover on this main duct, then press the tab key 1, 2 times, and on the second press, you can see that it highlighted all of them. So I'll click to select them, and then I'm going to click on Selection Box. Now here we can see the beam. I could also expand the box from the top, and even a little bit from the bottom. And up here we can see the units and equipments that have been placed on the roof, which are actually the chillers that have been placed. So as you can see here, we've got the ducts that we've just drawn, and therefore so far we've got one main line along with its branches. So now in the next step, we're going to have to place the fan coils, and after that we're going to get to the plenum boxes, and then we're going to be connecting these ducts and branches to those equipments.